So in this video, I'm going to discuss the happy students problem which often in today's LEETCODE challenge. So if you have any doubt regarding this, you can pin me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem statement is very simple. You're given a array or whatever you may like. You may also say that there was a list, and what you have to do is you have to select a specific group of students such that the students that are not selected, okay, having all of them that are not selected are having the value lesser than the number of students selected in the group, and the number of students selected in the group are having a value greater than the number of students selected in the group. Okay, I mean the value of each student. Okay, like I think it will be better if I explain you with this example. So 1 comma 1. So what you can do is you can select no student. So the number of students selected is 0, and all the other numbers, that is 1 and 1, it is greater than 0, right? So that one possible method is to select an empty group. Okay, and the other possible method is to select both the students, because if we select both the students, then there are 2 students and 2 is greater than 1, right, for both the cases. So 2 is greater than 1, so this is also perfect and this is also perfect. But what if we select any one, that is you are going to select that only this one? Okay, so this is not possible because the number of students is 1 and over here it is 1, so it is actually equal to, it's not greater or lesser. Okay, so it's actually equal to, so it is not possible. So there are 2 possible cases for this. There are 3 possible cases. One possible case is selecting 0, another is selecting 0, 2, 3, 3. So there are 4 students and all of them are lesser than 4. And another case is selecting all the students. So there are 1, 2, 3, 4, 5, 6, 7, 8 students, and all of them are lesser than 8. Okay, so there are 3 possible cases, that is 0, 0, 2, 3, 3, 0, 2, 3, 3, and selecting all. So this is the meaning of the question. So now let me discuss the solution. So I hope this, okay, so first you need a base case, that is base case. So before doing anything, you have to sort. Okay, sort the list. So once you're done with sorting the list, the base case is if the nums of 0 is equal to 0 or not. Okay, so if it is equal to 0, you don't have to do anything. But if it is not equal to 0, so let's say the result is initially 0, so you can make the result plus equal to 1. Why? Because you can, there can be a condition where you are not going to select any element, any student, okay, in the group. Okay, so that is for this case. If it is not equal to 0, that is nums of 0, so see, nums of 0 is 1, so it is, since it is not equal to 0, so we can say that we can select one such case such that no student is present. Okay, and then comes the main part. Okay, that is you can use a frequency array. Okay, frequency of size n, because it is given in the question that the numbers are in the range 0 to n. Okay, 0 to n, the nums, right? So you can make a frequency array of this n and iterate. Okay, so you know how to use the frequency thing. Okay, right, so what you can do is iterate I through 0 to n minus 1, and so you can find the number of elements that are going to be in there. That is, so let's say the size, okay, size is initially 0, so what you can do is size plus is equal to frequency of I, and then if the frequency is greater than 0, that is there was an element I present in the initial array, so in that case you have to check if size is greater than I or not, and if size is greater than I, you have to check if nums of size is lesser than size or not. Okay, if it is so you can make one thing, result plus plus. Okay, and then return result. So this is a little bit complex, so I will like make you understand this with this example. So first, if you sort it, it becomes 0 2 3 3, there are 2 6 2 7, right? So I think this is what it looks like after sorting. So let me draw the frequency array. So it is 0 1 2 3 4 5 6 7. Okay. So how many zeros are there? There is 1 0, 1 2, 2 3s, 2 6s, 2 7s, right? And the rest is 0, right? So this is how the frequency thing looks like. So initially, what is the base case? If num0 is not equal to 0, but over here see num0 is equal to 0, so we are not going to make result plus 1, so result is initially 0, right? Now we are going to iterate I through 0 to n minus 1, that is from here to here. Okay, so size is plus equal to frequency of I, right? So size is equal to initially 1, like after this operation it is 1. Frequency of I is greater than 0, yep. So if size is greater than I, is 1 greater than 0? Yup, it is greater than 0. And you have to check if size is if nums of size is lesser than size or not. So that is nums of 1, that is this 2. Okay, so is it lesser than 1 or not? So obviously it is lesser than 1, so you can make result plus plus, right? So result becomes 1. So why is it so? Because it was mentioned that when you're selecting a position, the rest of the positions has to be greater than that thing, right? I mean the size has to be lesser than that thing, right? And the size has to be greater than this thing. So this is a valid partition. Okay, this is the valid partition. So basically we need to find how many valid partitions are possible. So result equals to 1, right? Now we are going to go to 0. So now size remains the same, but frequency of is not greater than 0, so we don't need to consider this. For this again we need to consider this, so we are going to directly go to 2 and make the size as 2. Now check if frequency of, yeah, this is right, if size is greater than I. Is size 2 greater than 2? Nope, so we don't need to check this. Now we are going to go to this, that is 2 plus 2 is 4, right? Now again, is size greater than I? Is 4 greater than 3? Yep, it is greater than 3. And nums of size, that is nums of 4, right? Nums of 4 is lesser than size or not? So nums of 4 is 0 1 2 3 4, right? 6. So 6 is lesser than 5, yeah, sorry, 6 is greater than 4, I mean 4 is lesser than 6, right? So that works, right? So I think I made a mistake, so I think it will be nums of size is greater than size. Okay, so that was a slight mistake. I hope that was very much clear, like you guys already understood it. So now see, for this also that satisfies, so result plus plus, that is 2, right? Now we are going to shift directly to 6. So 4 5 6, so 6 and 6 are equal, so we don't need to consider this. Now we're going to shift to 7. So 6 7 8, so 8 is greater than 7, right? So 8 is greater than 7. And nums of 8, right? Nums of 8 is 0 1 2 3 4 5 6 7, right? So this is 7, so there is no nums of 8. Since there is no nums of 8, so we need to check another condition, that this and this, or if size is greater than equal to n. So if size is greater than equal to n, then also we can make result plus plus, because we are by default considering the next element as infinity. Okay, so the result becomes 3, right? So the answer, as you can see, it is 3. So this is how this code works. So this is basically the pseudo code for the problem. So I hope you understood it, and that's it from my side. Thank you.